ancient asteroids generated the hottest temperature ever recorded on Earth. And we've had a tremendous amount of them impacting Earth. How do they know what the temperature was? According to Nathaniel Sharping of Discovery, when an asteroid smashes into the Earth, things get very hot. It can boil the Earth, it can boil the atmosphere. It sets off earthquakes, fractures tectonic plates, it causes volcanic eruptions and nuclear winters with the ash clouds, and it's a chain reaction. Recently, a 17-mile wide crater, which is pretty small in terms of impacts, was found in Canada. It was home to what scientists say is the hottest temperature ever recorded on Earth's crust. Earth's crustal rock, they say it was 4,300 degrees Fahrenheit. They did not just stick a thermometer in there. The crater is some 36 million years old. Instead, what they did, researchers from Curtin University in Australia looked at the rocks, because embedded in the crater walls were crystals of cubic zirconia. It's a mineral that forms only under pressure of at least 4,300 degrees Fahrenheit, indicating that the force of the impact caused the surrounding rock to get at least that hot, melting it, if not even more scorching. It's the first time scientists ever looked for the crystals, and that has been going on a lot lately, and they have been finding that craters, especially the northern hemisphere, have been impact craters. First time scientists ever looked for a crystal, researchers say in a paper published in Earth Planetary Science Letters, offering a means of approximating the conditions of the meteor impacts. Meteors tend to vaporize most of the things they crash into. Rocks are included in that, so there's little activity actually left over, little evidence left over. Cubic zirconia, though, the same elements used to create artificial diamonds, by the way, survives in tiny fragments, and they act as a kind of a thermometer. Since we know what type of temperature is needed, what level of temperature, then they know that that was at least that level, 4,300 degrees Fahrenheit. Even though the heat would have only lasted briefly, the temperature was around half as hot as the surface of the sun, and far hotter than the inside of a steel forge. So these kinds of findings, methods, can help researchers better understand how early Earth evolved. Meteor impacts were much more common in the early days of our solar system. The planet would have been seeing thousands of such blazing impacts. Their force would have played a role in, of course, shaping the composition of the Earth's crust, altered the mixture of elements in our atmosphere, setting the stage for life to appear. Now, studying the aftermath of these impacts lets us see what took place in the past, millions of years ago. Now, the reason I'm coming up with this is like an introduction to the various types of unforeseen asteroid and meteor passages towards our Earth. We know that we have asteroid tracking systems by various space agencies, especially NASA, and on Space Weather they have a daily listing of how many asteroids we have, near-Earth objects. They're basically around 1,900 just about now, but they're finding new ones almost every day. Now, recently we had a small asteroid that was beyond the moon. It was supposed to pass us safely beyond the moon, and there was no doubt about it. The astronomers from NASA had no doubt it would not have come anywhere near our Earth, but unfortunately it did. It turned, and it impacted us over the Caribbean. This was a few days ago. And they were astonished, of course, and they started explaining that this has to do with the Yarkovsky, O'Keefe, Radzievsky, Paddock effect. We call it the Yarkovsky effect for short. changing its effect that changes the rotation state of astronomical bodies. The body's spin rate and obliques of its pole due to the scattering of solar radiation off its surface and the emission of its own thermal radiation. So, in other words, that means that the sun's rays heat it to the point where the surface temperature on the point facing the sun is heated, and that means that it's rotated, it changes temperature, and the effect of the material could be vaporizing because of the temperature or melting, and it causes the celestial body to spin and rotate obliquely at the poles, and it starts tumbling. And this is what they explain has happened to the asteroid a couple of days ago that was supposed to pass us. It was about 30 feet across. It was not supposed to be in any way coming near us, but it did, and it blasted over the Caribbean. So the Yorp effect, the Yarkovsky-O'Keefe-Radzewski-Paddock effect, the Yarkovsky effect for short, is considered for asteroids with their heliocentric orbit in their solar system. The effect is responsible for creation of binary and tumbling asteroids. And by the way, we were told recently that most asteroids don't come in on their own. They're at least binary, two that is, together, or in groups. So they don't, we usually don't have asteroids coming in one at a time and you're finished. That's why we've recently had an uptick in asteroids blasting fireballs or shooting stars, whatever you want to call them. Saturday morning and also Saturday evening, we had a big meteor strike over England, over Plymouth, and people called the police because they thought it was a crashing aircraft. It was not an aircraft because there were no aircraft missing, no accidents of aircraft reported, and the police have not found the pieces of that asteroid, the meteor, yet, but they believe that it could have been a small asteroid or a meteor type of a body that split into two, crashing into our atmosphere. It did not disintegrate fully, and it took, a witness said it took 20 seconds that was flying across the sky, 20 seconds. So it really surprised the people of Plymouth and the areas, and also people saw other shooting stars over the mid-United Kingdom and even far up in Manchester. So they do come in groups. Now, for important contributors, the concept of this Yarkovsky effect, which was found in the 19th century, Ivan Yarkovsky, realized that the thermal radiation from a body warmed by the sun carries off momentum as well as heat. Translated into modern physics, that means that each emitted photon possesses a momentum and its energy and the speed of light. Vladimir Radzewski applied the idea to rotating, tumbling that is, and others say it was shaped, that shape was a much more effective means of altering a body's spin rate. So there is a physical mechanism that takes place. In 2007, there was direct observation confirming the Yarkovsky effect on small bodies, such as 54509 YORP, designated 2000 PH5, and 1862 Apollo. The spin rate will double in just 600,000 years. And the effect will alter the axial tilt and the precession rate, so that the entire suite of the phenomenon can send asteroids into interesting resonant spin states and help explain the existence of binary asteroids. Observations show that asteroids larger than 125 kilometers in diameter have rotation rates that follow Maxwellian frequency distribution, while the smaller asteroids that are 50 to 125 kilometer size show small excess of fast rotations. The smallest asteroids, less than 50 kilometers, show a clear excess of very fast and slow rotations, and this becomes even more pronounced as smaller populations are measured. These results suggest that one or more size-dependent mechanisms are depopulating the center of the spin rate. So, in late 2013, asteroid P213R3 was observed breaking apart, likely because of its high rotation speed from the Yarkovsky effect. So, see here, the Yarkovsky effect not only makes it tumble and get out of its trajectory, it also, of course, causes the asteroids and these bodies to possibly break up and cause binary asteroids, or even more than binary asteroids, groups of asteroids, because they break up as they're coming in. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.